Welcome to our quick guide on kinematics for JEE main syllabus of Physics Unit 2 explained. One of the things that makes physics so fascinating is its ability to explain the motion all around us. And that's what we're going to dive into today. In just 6 minutes, we'll cover everything you need to know about Unit 2 kinematics. So whether you're just starting your JEE main prep or looking for a quick refresher, stick with me, let's get started. Imagine trying to describe the motion of a train. Seems simple, right? But motion is relative. Are you standing on the platform, or are you sitting inside the train itself? That's where the concept of a frame of reference comes in. We have two main types, inertial and non-inertial frames. An inertial frame is like standing still on that platform. There's no acceleration. But what if you're on a merry-go-round? That's a non-inertial frame, a frame that's accelerating. Now let's talk about motion along a straight path. We often use the terms speed and velocity interchangeably, but in physics they have distinct meanings. Speed is like the casual friend, telling you how far something is going regardless of direction. Velocity, on the other hand, is more specific. It's like that friend who gives you directions with precise details. Velocity is not just about speed, but also about the direction of motion. We need both magnitude, speed, and direction to define velocity. Now imagine a car taking a road trip. Sometimes it cruises on the highway, sometimes it slows down in traffic. Average speed is like looking at the entire trip, the total distance covered over the total time taken. It gives us a general idea but doesn't tell us the car's speed at any given moment. That's where instantaneous velocity comes in. It tells us the car's velocity at a particular instant, like when it was stuck in that traffic jam. Uniformly accelerated motion. A steady change. Now let's imagine our car is accelerating at a constant rate. This is called uniformly accelerated motion. To analyze this type of motion, we have a set of equations that are like our trusty tools. We have v equals u plus at to find the final velocity, s equals ut plus 1/2 at squared to calculate displacement, and v squared equals u squared plus 2 as to relate velocity, displacement, and acceleration. Remember, these equations only work when the acceleration is constant. Graphical representation. The power of visuals. Graphs are amazing tools because they help us visualize motion. In kinematics, we often use velocity time and position time graphs. A velocity time graph plots an object's velocity against time. The slope of the graph tells us the acceleration, and the area under the graph gives us the displacement. Similarly, a position time graph plots the object's position against time. Relative velocity, shifting perspectives. Let's go back to our train example. Imagine you're walking inside a moving train. Your velocity relative to the train is different from your velocity relative to someone standing on the platform. That's the essence of relative velocity. It's about how the velocity of one object appears from the perspective of another moving object. If two objects are moving, their relative velocity is determined by subtracting their individual velocities. Motion in a plane, 2 dimensions, unleashed. So far, we've mostly explored motion in a straight line, but the world is rarely that simple. Objects often move in 2 dimensions, like a ball thrown in the air, or a car navigating a curved road. To describe this kind of motion, we use vectors. We break down the object's motion into horizontal and vertical components. Projectile motion, a classic trajectory. Think about a cricket ball hit for a 6, that's projectile motion. The curved path an object takes when thrown or launched into the air. It's a combination of horizontal motion with constant velocity and vertical motion influenced by gravity. We can calculate the range, time of flight, and maximum height of the projectile using specific equations. Uniform circular motion going round and round. Imagine a Ferris wheel rotating at a steady speed. That's uniform circular motion. Motion in a circle at a constant speed. Here, although the speed is constant, the velocity is constantly changing because the direction of motion is always changing. This change in velocity leads to acceleration, called centripetal acceleration, which always points towards the center of the circle. And for this acceleration to exist, there must be a force called centripetal force, also acting towards the center. Outro, keep exploring the world of motion. That's a wrap on kinematics for JEE main of physics. We've covered a lot of ground today, from frames of reference to the intricacies of circular motion. Make sure to review these concepts and practice problems to master this unit. Don't forget to like, share, and subscribe for more quick guides. Keep that curiosity alive, and I'll see you in our next video.